Sometimes when we make a program, runtime errors can occur. So for example, if we divide by 0, then run, that's a runtime error. Most runtime errors are known as exceptions, and basically an exception is basically a runtime error, where runtime error is basically an error that occurs during execution. Normally what happens with runtime errors is that anything that happens before the runtime error gets executed, but anything that happens after the runtime error is not executed because the program exits as soon as it hits the runtime error or exception. So this divide by 0 would be arithmetic exception. More examples would be like, for example, accessing a method or variable of a null object. That's a null pointer exception. So if we get rid of this arithmetic exception, note that if we don't get rid of that, it'll first hit the arithmetic exception, then not be able to hit the null pointer exception. So accessing a method or variable of a null, basically null pointer exception. Another example would be like, say, array index out of bounds exception. So if I try to access index 3, then it would compile, but again, as soon as I try to run, it's an exception. And then say misusing string methods, like making indices that are out of bounds, string index out of bounds exception. So if I have this, then it would be a string index out of bounds exception. However, if I had s.char at -1, it would be a null pointer exception. And there's plenty more types of exceptions. So now, why do we want exceptions? Well, generally, exceptions are when there is a problem. So if we didn't have exceptions, then clearly we're not supposed to access -1 from an array or a string. So how would we do it? We would have to give wrong answers. And the problem with wrong answers are that wrong answers are almost always harder to detect than runtime errors. Because the wrong answers, well, first you have to get the correct answer, then you have to get the reason. However, a runtime error, as you see, if I make a runtime error right here, first of all, it'll specifically say what type of error, like what type of exception, maybe some details, and then it even says what line number I did it on. So line 6, and then whatever that method calls all the way down to the bottom. Usually it's the reason, usually this is the reason, the top line. So then basically we can detect it, and then because we know what error or exception it is, and we even know what line it's on, so then we can easily pinpoint the problem. Wrong answers, on the other hand, you can't have that. It's much harder to detect. Now, sometimes we may want to throw our own exceptions, because basically, what if technically something serious is wrong and we know that no matter what happens it's wrong, but technically it doesn't automatically throw one of these obvious exceptions. So for example, let's say we have this method right here, and let's just say if a negative number is passed, then wrong answer. And plus, not only wrong answer, but probably there's something seriously wrong with the program that's calling this method. Basically, in terms of the logic of the code, why would you pass negatives? So therefore, we may want to tell the programmer of a client program that basically you shouldn't be doing this. So how do we do that? Well, it turns out we can throw exceptions. So basically, all you have to do is throw like that, and then say new, and then the type of exception. Now for this one, if n is less than 0, usually you provide a condition before throwing one of these, because you don't want to always throw one of those exceptions. That's dumb. So then throw new, say, illegal argument exception. You don't have to memorize the names of the exceptions, just like, first of all, you must know the important ones, like arithmetic exception, null pointer exception, array index out of bounds exception, maybe string index out of bounds exception, and maybe input mismatch exception if you're working with user input, and IO exception for input and file input and output. But you don't need to like know every single name of every exception. This is just another one, illegal argument exception. So I passed in argument cannot be negative. So now, how does this throw work? So first, how do exceptions work in general? So exceptions are also classes. So basically, all exceptions extend the exception class, which extends the throwable class. And basically, what this means, so basically all exceptions extend the exception class, including, for example, illegal argument exception. And exceptions are just objects as well, just like other objects, because this exception class definitely extends object. So basically I create an illegal argument exception object. I could even do something like, say, for example, illegal argument exception e equals new, and say this thing. And then I can do, say, throw e. That would work as well. Basically the point is, how do you throw an exception? You basically throw an exception object. It's that simple. Now, what happens if you throw an exception? So first of all, factorial with 3 passed in, say, is not going to cause a problem. Let's say I pass in -3. Then it will definitely throw the illegal argument exception. How will Java do this? Basically, whenever I throw an exception, it causes an exception to occur. So basically now we have this illegal argument exception right here. And in fact, most exceptions allow you to provide details in their constructor. So basically, argument cannot be negative here, so argument cannot be negative here. And then basically now I reach an exception and my program ends. Remember, as soon as you hit an exception, if you don't handle it, which we'll talk about in a bit, then it will cause the program to end. So therefore the program will end, but more importantly, the programmer will know that a serious problem occurred because I somehow passed a negative number into factorial, which shouldn't happen. Now, all of the exceptions so far, these that we've gone over in this video, are unchecked exceptions. So basically, unchecked exceptions are subclasses of runtime exception And basically, we can just directly throw them without compilation errors. So basically, throw new runtime exception, and that would work. Basically, it wouldn't cause a compilation error. There's also checked exceptions, which are exceptions that need to be declared in a method header. Notable examples of checked exceptions are, well, first there's exception, which the superclass of all exceptions, because, well, exception does not extend runtime exception. It's the other way around. So exception is checked. Say IO exception. If you recall, that was the exception for file input and output. So basically, what do I need to do for checked exceptions? Let's just say I want to throw a new exception for some reason. It says unreported exception, java.lang.exception must be caught or declared to be thrown. So first we'll talk about declared. So in order to declare an exception, we just, right after the header of the method, I just do something like throws. Notice throws is different from throw right here. Throw is an action. Meanwhile, throws is an indicator. So throws exception. And then it works. Another example is, for example, throw new IO exception, where I need to import java.io. So without the throws, it doesn't work. I need to do throws IO exception. It turns out actually I can be lazy and just say throws exception, because technically an IO exception is an exception. But it's more advised that you not be lazy, because there can be other exceptions. If there are, then you might not know. So therefore, sometimes you can just be lazy if you really think that your program isn't going to have problems, but we're going to put IO exception for now. And actually, another thing is that if you call a method that throws an exception, so first, let's say this method throws, so calls, like, basically uses throw new, say, exception. Then I would have to say throws exception. Or say throws new IO exception. I could do throws exception or throws IO exception. Let's just put IO exception for now. Suppose that this main method did not have a throws IO exception. Now I call X. What's the problem? Well, I did not directly throw IO exception in our method. However, I called X, and X has a potential of throwing IO exception. So therefore, what we're saying is basically now main method also has a potential of throwing IO exception. Therefore, I need to declare it in there. So now it works. This also explains why we need throws IO exception for file input and output. Let's just say I have a print writer. And let's just say for some random reason, I didn't give Java permission to write to files. So then there would be a file not found exception, which extends IO exception. So therefore, since the constructor of printWriter could potentially throw an IO exception or a file not found exception, I must put throws file not found exception like that, or just throws IO exception because it's shorter and is still in the general area. I could also put throws exception if I'm really lazy. But anyway, that's the point. Same thing with a scanner that reads from a file. So these two are so far notable checked exceptions. Now, so far, all exceptions, basically, as soon as I encounter them, I exit the program. What if I don't want that? Like, what if I know that an exception could occur, but I am equipped to deal with the exception? Well, it turns out you can use TryCatch Blocks with potentially finally. So, first of all, what is a TryCatch block? Well, basically, a TryCatch block is basically a block where, and by the way, TryCatch blocks work for both checked and unchecked exceptions. Basically I'm saying, let's just say I have some code right here that potentially causes an exception. So like, let's just say I have this code, which we know is going to throw an exception. But let's just say it potentially throws an exception. Now, let's say we're equipped to deal with that, because usually arithmetic exception is not that big of a deal sometimes. Like, sometimes it is, but sometimes it's not. Let's just say it's not in this case. So then what do? I can use a TryCatch block. So how TryCatch blocks work is that basically first we put the potentially errored code inside of the try block. Then afterward, if an exception is thrown, then basically it will try to catch the exception. So basically, what does that mean? That means that it'll try to find among the catch blocks which one is suitable. So how do I tell whether one's suitable? Well, basically, we check by the name. So let's just say I have like that. So basically the way this thing will work is I first run the program. Then if there is no error, so basically let's just say I have normal code, then all that happens, by the way, these are all runtime errors. So if no runtime error occurs, then basically what happens, so if I get rid of the factorial of -3 right here. So really all that happens here is that the program runs normally. So basically everything in the try block is executed. So this A is printed, B is printed. And then it skips all the catch blocks because no actual exception occurred. Then it continues on with the program. Note that there can't be like any statements in between try and catch blocks. So if I try to do this, not allowed, because this catch block is basically separated from the try block. So that's not allowed. Similarly, I can't put a print statement between two catch blocks like this. That's not allowed. Unless I put another try, but that's a different story. So now, what happens if there actually is an error? Say I print 5/0. Then basically what Java does, first, let's go through this. It prints A, that it tries to print 5/0. Now, we all know that's going to cause an error, or runtime error, or an exception. So first of all, it checks, is this thing a null pointer exception? No, an arithmetic exception is not a null pointer exception. Is this thing an arithmetic exception? Yes. So therefore it prints divide by 0. Then afterward, remember, once an exception is caught, the rest of the try block is skipped, since it's probably flawed code anyway. So then basically Now it prints divide by 0, and then all of a sudden I don't print B because I already quit the try block. There, an error occurred. And by the way, I only go to one catch block. After I do the catch block, I'm done, and then I print ABCD because this code is immediately after the catch blocks. Like so. Notice B is not printed. Another one, let's just say I try to print, I cast a null to string for some reason and access dot length, and then it's just going to say null object because, well, is it a null pointer exception? Yes, so I skip the rest of the catch, and I print null object, I skip the rest of the try as well, and then I print ABCD because that's after the catches. Now, what about the following? Say I have an array, and then I access index -1. Again, no compilation error, and then unknown error. So why is that? Well, first, this is an array index out of bounds exception. Is it a null pointer exception? No. Is it an arithmetic exception? No. Is it an exception? Yes. Notice that exception is catched last, and this generally means that basically if it's none of those two exceptions, then we catch it. So basically every exception is an exception. So this array index out of bounds exception extends exception. Therefore this works. It successfully caught and it prints unknown error. And then the program proceeds normally after that. Now suppose we did not have this catch block. So basically in that case I did not adequately catch this exception. Then what will happen? It turns out it's just going to cause a normal runtime error because I failed to catch the exception. And now, why when I did say 5/0, did it skip over this exception? The reason is because I already did the arithmetic exception. And once I reach a catch block, I skip the rest. Basically, I go to the first available catch block, and only the first available one. Now, suppose I wanted to know the details to the error. We know that we get the details to the error if we throw an exception and don't catch it. Now, what if we want the details to the error anyway here? Well, I can do the exception dot print stack trace. Basically what's going to happen, and it's going to print unknown error because duh, that's what we did. Then e.print stack trace because that's what this thing is. And this basically gives you the details. So for example, line 44, which is the line that caused the error, we have an array index out of bounds exception right here, which is useful because even though this thing is generally treated as an exception, since we're calling a method, it calls the array index out of bounds exception method. So therefore, it can even tell us what type of exception it is. One last feature of handling exceptions is a finally. Say this will always happen. So basically, how does a finally work? Basically, if the program runs normally without an exception, then it's going to be executed. If the program catches an exception, it's still going to be executed. If the program fails to catch an exception, well, it's still going to be executed. This will always happen. So basically, in other words, finally is something that is always executed no matter what. There's two exceptions. One is if I say throw an exception inside the finally or do something like that. So I throw an unchecked exception or a checked exception. Then, boolean b equals true if b. So basically, if we throw an exception in the finally and we don't successfully catch it, then the finally won't run entirely through. It'll still be executed though. The only other exception is if we explicitly exit the program, like system.exit 0, but that is a rare case. Basically, let's not care about that. But in general, the finally always gets executed. Now, what's the use of a finally? Now, here is a use. Let's just say I create a file. Now, suppose we just had this code right here. Now, what's this going to do? Create a.txt, print A, print B, cause an error, and then exit the program. However, notice that we haven't closed the print writer, which means that this file won't save. So what does that mean? That means that it'll cause an error, an arithmetic exception. Then afterward, the file is empty, which may not be what we want, because maybe we printed some important information. Maybe the program takes like hours to run, and then we got some information, and we caused an error, and then all of a sudden, all our work is lost. That's not good. That's really not good. So instead, what do? Instead, we can use a try finally block with potentially catches to avoid some errors, but anyway. The point is, finally, now, basically, we run the program. Now we know there's an error, so we stop the program. However, notice now, so we create a.txt, we print A, print B, cause an error, so then we quit the try. Now, there is no catch, so it's actually not successfully caught. Then it'll go to the finally and close the file. So now, when we run the program, it's going to basically, when I open a.txt, it has A and B. And let's say instead of A and B, it was actually some really important information that took hours to get. Well, it would be lost if we didn't have this finally, just because of a simple error.